Lesson 7, we're looking at solving inequalities. So Henry is thinking of a number less than 17. What number could he be thinking of? Again, like we talked about yesterday with inequalities, we have more than one option. So a number less than 17, one option would be?
12. 3.
3, 12. 4. 16. Good. Okay, so lots of different possibilities. We're going to be looking at, in this lesson, how we can make a graph on a number line to show all the information of possible solutions without necessarily listing out every single option. So example 1, inequalities use these symbols to compare two expressions. Graph all the solutions of x is greater than 5. So if we want something greater than 5, we're going to do this a little bit differently than the book is doing. One thing we're going to do, though, x is greater than 5, we're going to put an open circle on the number line. We're actually going to put ours above the number line rather than below it, or rather than on it like the book is doing. The open circle is indicating that it's not including 5. Does not include 5, it's an open circle. And then step 2, they said find some solutions. So we know numbers greater than 5 would include 7, would include 9, for example. So anything that direction is going to be part of our solution. So then they put a line and an arrow going to the right of that open circle. Again, rather than doing it like the book is doing, it's easier to see, and you will have to sharpen your pencil, use less lead if you just do this above the number line rather than on it. Okay, it's a lot easier to tell what direction your answer is going. So that's how we're going to do this. So one thing going along with that then, if you have greater than or less than, when you graph these inequalities, you're going to do an open circle, and that means it doesn't include the point. So open circle, kind of like this. Open circle does not include that point. So to try it, they want us to graph all the solutions of x is less than 8. So to graph x is less than 8, we are going to draw what kind of circle? An open circle at 8 on the number line. And then we draw an open circle at 8 above the 8. And we just think of some numbers that would be less than 8. So they said 7 and 4 are a couple of examples.
Why can't you just put a circle? Like, why do you have to call it an open circle? Because it's not filled in.
It's not filled in. So we're just calling it an open circle. Okay, so 7 and 4 we can see are to which side of the 8? To the left. So we're going to shade solutions to the left of the open circle we drew. So from our open circle, we're going to go to the left. And again, just put an arrow on the end to show that we can continue going that direction. Sometimes in real life situations, maybe negative numbers don't make sense. They didn't tell us anything about what's happening, so we're going to assume even negatives would be okay for this graph. Example 2, the barbecue beef dinner entree is the most expensive menu item. Some of the costs of the entrees are shown at the right. What are all the possible costs of the menu items? So if that is the most expensive menu item, that means that the menu items are all less than or equal to $12.25. This includes the $12.25 or anything less than it. So rather than just like the book says, rather than listing out all the different options, just a quicker way of doing that is graphing it. So this one, since it's less than or equal to, we'll talk about more in a minute, that's going to be a closed circle because that includes the $12.25. And then we're going to go to the left for the points less than that Technically, this one would end at 0. Technically, we would not go into the negatives. So, technically, you could argue to put a dot at the 0 rather than having an arrow on the end of that. But that's what's happening here. And again, like I said, basically, we've got greater than or equal to or less than or equal to. It's going to be a closed circle, and that means it includes the point. So if you have or equal to, that means it includes the point, and we'll do a closed circle on our graph. So if we look at the try it, there are no menu items on the children's menu at the museum restaurant that cost more than $8.50. What are all the possible costs of the items on the children's menu? So similar idea. Nothing's more expensive than $8.50, but $8.50 could be a price. So we would include that. So we would have a closed circle at $8.50, and if it's otherwise costing less than that, we would go towards the left. Again, technically ending at 0 here. If we were doing an inequality, they didn't ask us to do this, we would say our cost is going to be less than or equal to $8.50. Example 3, a long jumper who jumps at least 18 feet qualifies for the finals. Which athletes, if any, qualify for the finals? So at least 18 feet, so you can see Amir went 22 1/3. That's more than 18, so that's good. Jake is 16, so that's not enough. Tyrell is 18 1/2, so that's enough. And Ryan is 20 1/2, so that's enough. If somebody would have jumped exactly 18 feet, would they have qualified for the finals?
Yes.
Yes, at least 18 feet, so that would work. And then the try it, which athletes, if any, would qualify if the length of the jump were at least 20 1/2 feet. So at least 20 1/2 feet, who would have qualified?
Amir and Ryan.
Amir and Ryan, good.
I didn't know Amir could jump that far. Oh, yeah, Amir.